Hello and welcome to Industry Perspectives Telecommunications Facility. My name is Bhavesh Patel and I'm Vice President of Global Marketing at ASCO Power Technologies, a Schneider Electric business. I'm very excited to host another session of our Industry Perspectives, which have been consistently averaging hundreds of live attendees. I truly appreciate all your support joining live and asking questions and hope that you learned something new today. I've had opportunity to present at various conferences, published articles, etc., so I can continue to build and add to the body of industrial knowledge. And today's another such event where we want to continue building that body of education for any critical facilities, electrical infrastructure. This event was recorded earlier, but we will have live question and answer sessions. So please start thinking about and populating your questions in the questions link of this webinar tool. This event will earn all attendees a professional development hour, and you may also qualify for a continuing education unit or CEU once you successfully pass the quiz. Now today, I'm really honored to discuss topics related to telecommunications facility with Bablu Kazi, professional engineer at Morrison & Hershfield, who has many years of experience designing telecom facilities for many companies. Hello, Bablu. Welcome to Industry Perspectives. Can you please introduce yourself to our audience?
Hi, Bhupesh, and hi, everyone. My name is Bablu Kazi. I have been doing mission-critical facility electrical infrastructure design last 20 years. I graduated from Georgia Tech. I have been working in Atlanta office of Morrison Hershfield for 17 years. My previous life, I work on non-mission critical facility industry, but over the year, mission critical facility is my passion, and I design a lot of data center all over the countries, from California to New York, you name it, and from Florida to all the way to Minnesota. So I have been doing nothing but mission critical facility design last 20 years. So I did a lot of telecom facility switches. Start from cell tower. I designed cell site. Start from there, but all the way I'm doing a lot of switching facility, various company, including AT&T, Verizon, T-Mobile, Nextel, you name it. I've done all of them once in my life.
Great. Thank you, Bablu, for joining us and sharing your knowledge and your experience with our audience. So for the audience, today's conversation will focus on the electrical infrastructure of telecommunications facilities, and we will break our conversation into 4 key topics. The first will be the COVID and its impact on telecommunication facilities. Then we'll touch on the telecommunication facility design strategies. Then we'll move to the telecommunication facilities and sustainable electrical infrastructure. And then we'll finish off with telecom facilities and the Internet of Things. So Bablu, let's start with our conversations. So telecommunication industry has been evolving for a lot of years. And it seems to me that this COVID situation maybe have accelerated that change. But today, it is very tough to differentiate from a telecommunication or a media or an entertainment industry because they seem to be blending. So, for example, AT&T is no longer just the Ma Bell that everybody used to call it a few years ago. So can you share your perspectives on what has changed in the telecommunication industry?
Thank you for the question. It's a great question. I want to share it was as far as the industry's perspective and our real life perspective, how telecom changes. For example, when 15, 20 years ago, we had land phone in everybody's house. I can show you one, and I'm holding one. This is we used to have. That used to be just make connection from one to another, just make a phone call. We cannot see anybody, just talking to each other to communicate each other. And from here to long distance, anywhere you want to call, you just talk. That's all we have. Over time, telecom from LAN to migrated to wireless. Initial wireless phase, we had flip phone. We can just, what we're doing from LAN phone, we're doing exact same thing with the wireless phone. Now, here's come a smartphone. When the smartphone comes, it's not really a phone. I can show you one, what we have in hand. Is this phone has computing capacity. This phone computing processor is more powerful than the computer we use to send Apollo 11 to moon. And that computer took several rooms. That computer itself took 10,000 square feet of spaces to process to send the moon. We can do same thing with this phone. It's actually more powerful, has more processing power. Now, in terms of the COVID-19, we had a lot of features we used, but we never realized how useful telecom give us opportunity and evolving the new technology we use every day. We never knew the real meaning until the COVID hit. For example, before we have a meeting, in my office, we gather everybody, go to the room and have a meeting. Now, I can use my phone or laptop, what are we doing? We're using telecom, and we are doing Zoom meeting, Microsoft meeting, whatever meeting you name, we're using our phone, and we feel like each other. We never realize that it's going to happen to our life, so we're talking to each other. We're seeing each other. We are showing equipment. Everything is done by this phone. Also, one thing happened to my life. I didn't realize it either. I was playing soccer. Foolish me, this age, we shouldn't play soccer, but after playing soccer, I had my knee hurt. So was locked down. Doctor cannot see me. I called my doctor. Doctor said, hey, we can do FaceTime, and figured out what's problem he had. And we had a FaceTime, and she looked at it, everything, give me medicine over the counter, and I take the medicine, I feel better. Then she follow up with the FaceTime and look at my body, everything. I feel like I was in a doctor office. So many things is COVID-19. We learned our phone, evolving of the telecommunication, useful to our life. We knew it, but we never realized it. How useful is this? Now, after COVID-19 hit and we forced to work from home, especially work from home, I cannot imagine work from home without telecommunication. And we cannot do what we're doing and without telecommunication. So telecommunication is a big part of our life. Also, the whole society changes happening during COVID-19. Thank you.
All right, so the next question is that until about a decade or so ago, maybe even more, that many people had a dedicated telecom-only connection, and you shared your device for our viewers. Now, some of those fixed devices only were capable of voice conversation, again, as you touched on your earlier answer, and they mostly were based on analog technologies. But now with mobility, the digitization, that fixed device, especially a fixed device for voice conversation, is disappearing, and disappearing fast. So then from an electrical infrastructure standpoint, how much of that older infrastructure is still useful today? If you can walk us through that journey of evolution of the electrical infrastructure as the fixed device is disappearing.
Great question. Bhupesh, we need to work it through from, say, we have LAN to wireless. As I said before, LAN is disappeared totally, landline. I think it's very few people who have landline in our home. And useful of LAN is gone. So all the evolution happened in telecom is wireless. Wireless made telecom become, it's not telecom, it's not telephone anymore. It's migrated with their phone to a total essential device. It's include, like before I told you, my phone, this phone, I have phone, my TV, my computer, my work, and I can use this one for my house key. I can use for my car key. It's like used to when I go outside. I remember when I was in college, when I go outside, I make sure I take my key and my wallet. In a few years, or probably start now, when you're going outside, all you need is your phone. Phone will have everything: your house key, your wallet, and your computer, everything in one devices. So having that, what's the evolution happen? So we go through some of the thing and how affect the infrastructure on the infrastructure we see. First, take a look what happened in the wireless. In early late 70s, the wireless started. We call 1G. G means the generation. So 1G is the first generation. It was analog device. We have probably one or two cell tower in the city, and few people can afford to have a big phone. The phone was as big as like a microwave. It was that big, and it takes like it's nowadays senior citizen big bottom they have. That we had the initial phone. From there to evolve to telecommunication evolved, there's more people coming to wireless. What happened? Infrastructure changed. More demand got on an infrastructure. So we go to 2G. 2G also analog devices, but a phone got is smaller, and we have more user coming in there. More user means more cell tower. More now used to be central switch to a mobile switch. They start doing it to in the city. Used to be they use own LAN switches to mobile do that. Now they need their own switches. They start doing switches, which is switches in another sense is exchanges. So we get from 1G to 2G. The 1G, 2G still is a more user, more cell tower. Now they start looking at cell tower is not enough. So they start go to 3G. 3G, they start putting rooftop antenna. It's making closer to it because there's more user coming in there, and there's more demand coming in there. So infrastructure grow significantly. So we need rooftop in there. And from 3G also is converted from analog to digital. When digital happened and same time a smartphone hit to the market, first iPhone and introduced, then whole ball game changed. So what happened now, need for infrastructure upgrade, telecom industry realized that it's like old infrastructure not going to work. They start making big switches. That big switches, telecom is always head of the game. So they start overbuilding it during that time. So for example, they need a 1,000 amp service. They bring in 4,000 amp service. So up till now, which is 4G, still that infrastructure is valid, because they over-designed it. But that will disappear very quickly. When the 5G comes, will change all the ballgame. A 5G require more infrastructure, more electrical processing power, and it require more power density. And what happened? Let's give you an example. What is the 3G to 5G? What's the thing in it? When you have 3G, we download a movie. It takes 26 hours to download a movie. When we go to 4G, it takes 6 minutes. But you all have kids in your home, or some of them you have probably have kids in your home. I have a teenager in my home. She needs immediately everything. When I have Netflix, she cannot wait 6 minutes to there. So now here's come 5G. They're going to meet some of the need, what she asking for. Now it's going to take a whole movie download in 3.5 seconds. So you saw you think this is like we're changing the phone and everything and nothing happening behind the scene. No, we're seeing the behind the scene stuff. That's normal people don't see. What happened, this effect happening in infrastructure. The old infrastructure, beside fiber, getting more obsolete day by day. So you need a bigger infrastructure, more power density, more power connection, more cooling, a smart way to do stuff. We are still looking outside the box. So existing infrastructure, yes, it can help us to get it there, but it's not enough. So we need new infrastructure very soon, and telecom industry is finding that in a hard way.
Great. Thanks, Bablu, for that answer. Again, I want to remind our audience to start asking questions that they would like of Bablu and posting them in the questions block of this webinar tool. So Bablu, now let's move on to the second topic surrounding telecommunication facility design strategies. So as we touched earlier, there is blurring of lines between telecom and either entertainment or media or both industries. So from that blurring of lines standpoint, what is happening in the electrical infrastructure design strategies for these facilities? Can you share some of the trends that you have noticed so far?
Yes, a great question. Actually, is having huge impact on electrical infrastructure. Before I go there, I'm going to give you a little bit of background to understand where are we going in there, why we need the upgrade of the infrastructure, what's triggered this. First, we need to understand the telecom invented in 1876, Alexander Graham Bell. From there to 4G, whatever is 145 years of telecom industry background. Whatever happened, involved innovation, everything happened. Everything gonna change when we go to 5G. 5G will be, I'll say, it will be game changer coming in there. Why? 5G will affect every aspect of your life. Before I go to details on 5G, let's explain two things happening in data center and throughout the world. Biggest thing in the data center we built a lot of multi-data center throughout the country. But what happening is some of the data center far away from where the end user is. So now we are realizing to have a 5G, you have to have a local processing. Local processing, when you have local processing, it needs the edge data center. So edge data center, which is filled by telecom, and I'll explain it that a little bit better, but I need to explain one more thing, why we need to have local processing. The biggest reason we have to have a local processing, latency. Latency, what happened, like if you send a data to here to California and it's coming back from you, it's take probably a 0.1 second, or could be 0.2 second, or even could be a second. Sometimes you don't have that second. Let me give you an example. You have a refinery, and you have a pressure built up in the refinery and has an auto shut-off valve. If that shut-off valve is monitoring from 3,000 miles from Louisiana to California or somewhere else outside of the country, by the time they get the signal coming back and shutting down that valve, it could be a disaster already happened. What do you need to happen to migrate that disaster? You mitigate that disaster. You have to change that to a local processing. That's where is the edge computing coming. The biggest thing we need for 5G is the edge computing, and also 5G network also has some disadvantage too. It's not like a 4G and other stuff. It is you have a cell tower in 3-4 miles away and it's going to work together like that. No, 5G, even 3 block the signal. Building block the signal. So you need more power. There's a study found that we need, USA want to go 50% of the 5G within 5 years. It's 2025. It's not 5 years anymore. We already lost a year. It's 4 years. We want to go ahead of everybody. So we want to change our infrastructure to 5G in 4 years. So what we need to have? We have 100 million more cell tower. We got to build more edge computing, which is they call telecom. They call it MAC. MAC is, there is a 2 name for MAC. It's basically edge computing, multi-edge computing or multi-access computing. Whatever you say, it is edge computing. This edge computing will require massive infrastructure. For example, telecom had 2 watts in a server. They didn't have server, but they transitioned to server because of our need. Because what I said before, it's not phone anymore. It's a total package. So they become data center instead of switching center. And transition to data center, their power density goes up. What is the electrical have biggest effect? Used to have 1 to 2 kW per rack. Now we are looking at 10 kW. I think within 3 years, that's going to be 20 kW. So it's going to affect our electrical infrastructure. We need more cooling, more so fiber. A lot of things has changed, and that cannot be converted. Same time, another problem telecom has, we have to keep the 5G alive. 4G alive. To 4G, keep it alive, so you cannot touch existing infrastructure, and existing infrastructure not built such a way you can adapt it quickly for 5G. So new infrastructure has to build, and has to build quickly. I told you the time frame. We only have 4 years to build 50% of the people in this country. It's a massive. Also, edge computing. Let me go back to edge computing. To have 5G successfully done, we need to have edge computing 75%. Right now, we're doing edge computing only 2 to 3%. So you see the need for that. Also, the latency, what I talk about, for 5G, only 0.001 second. So you're talking about almost nanosecond level. And that's how quickly it could be done. That will affect really our electrical infrastructure. Thank you.
Great. So let's then move on to the next question. I mean, you touched on a lot of things, and you, I think, shared with our audience a lot of layers that make up this evolution in the telecom industry. So then, looking at all the things that you mentioned that needs to be done to prepare for and sustain 5G, let's look at this from an electrical resiliency standpoint. Obviously, telecom industry has been focused on electrical resiliency forever. But what you just pointed out, in my mind, further magnifies the need for electrical resiliency. So can you share for our audience what has already been done to improve electrical resiliency and what still needs to be done to continue building and improving resiliency?
It's a great question. I think it's until few years. Well, I'm doing telecom, let's say last 20 years, until first 17 years, what I see, last 2-3 years, I'm seeing totally 180 changes. Telecom facility infrastructure, people are conservative. They want reliability. They don't want phone lines to go down. You know, there's a lot of time in local news. If you have, my AT&T service gone, you will be in the news right away. Or T-Mobile not working, or Verizon not working. It is going to be local news. What telecom want to avoid, this is the biggest peer event. They don't want to go down their infrastructure or something happen. Also, your smartphone become your 911 call, emergency too. So if something shut down, you think you are shut down your emergency. How many people has land phone? I'm going to ask this question over and over. And very few people. So using 911 through phone, even text it right nowadays for your 911 call. So having that, what happened the electrical infrastructure? They used to have a DC power base. DC power is very reliable, and as I say, power density was not that much. So as long as you have 8 hours, 4 hours to 8 hours, depend which telecom industry you are, which company you are, 4 to 8 hours of battery backup. So 4 to 8 hours battery backup. If you lost power, you still have few hours to react. And you open the door because the cooling is not that difficult. Your power density is not difficult. It takes a long time to heat build up. You open the door, put some fan in battery power and run in there, and everything should be good. But that changed. As I say, when it started changing the 4G, but 5G will be better now. Now we need a lot of power with a small footprint. How are we going to do it? 48-volt DC cannot do it anymore. It cannot be done because 48-volt DC, if you have two 10,000 amp plant, it takes 50,000 square foot of infrastructure to do till two 10,000 amp plant with a couple of switches. Now, that's going to give you 600 kW of power. That is nothing. Now we have 2 megawatt, 3 megawatt, 4 megawatt power requirement. If we need 2 megawatt, 3 megawatt power requirement, also our building footprint is not going to get bigger. Is real estate getting difficult to get, and it takes time to get a new real estate build stuff. As I said before, 5G is behind our scene. It was already started. In the 4 years, we got our 50% people need to have access to 5G. So what was happening electrical in there? So we need to convert it from DC to AC. To having converted to DC to AC, we need to consider the resiliency of the electrical infrastructure. Now we are reliability instead of DC coming to AC. What happened to when coming DC to AC? Why are we coming DC to AC? As I mentioned before, you only have 600 kW you can do with the DC power with a 50,000 square foot. Now we can do a 20,000 square foot of building with a UPS, which is, I can do a 2 megawatt in 20,000 square foot. Look at this. I just multiply 5 times and reduce my footprint 2.5 times. And to having that, what else have to happen? Now, power generation. Utility is I always say utility is our cheap power. Generator is the real power. So we got to have redundant generator, reliable generator, a lot of transfer switches, because traditional people getting away from paralleling systems. So, and also when you're building a block, we are not building a massive thing anymore. This is true for data center, true for telecom, everybody. We're going to build as a block. When you're building as a block, it's better to have generator with the transfer switches and as simple as possible. And we are thinking outside the box. We are coming out with a redundancy. That redundancy going to help us to make sure we don't have any outage. Our end goal, no outage, no matter what's going on. So this outage, it forces us to innovate a new electrical infrastructure, and that is changing rapidly. Thank you.
All right, great, Bablu. I think you've given a lot of things for the audience to think about. So again, I want to remind the audience, if you have questions to ask of Bablu, please start populating your questions in the questions block of this webinar tool. Now let's move on to our third topic, which is telecom facilities and the sustainable electrical infrastructure. So Bablu, in this evolution that you painted a picture of for the telecom industry, what role, if any, does sustainable technologies have within the telecom industry?
Great question. And we will tell you, I'm going to start this answer to you. If you have a teenager in home, the biggest punishment we used to do before is take them and say, sit in the timeout, go to your room. You cannot talk to, come out of the room for a few hours. Now that's punishment change. Now my teenager doesn't listen to me. I take her phone away. So you understand how important the phone is our life is. That's what's the resiliency of the telecom count. Starting from there, I'm going to explain more in details. Let's see, for example, I keep talking about 5G because this is the 5G will change our life. I believe it. I see it. What I see it. What I'm reading it is gonna be game changer. What 5G does is a cloud-based technology. Is use software shopping. So what happened in your need for the gaming is different than my need for video call or phone call. So each one they chop your cloud to different section to you can use the existing frequency. Still you can meet everybody's need. So that's the resiliency telecom found themselves, and they're ahead of the technology always. Telecom think outside the box and thinks what's happening next 20 years. So having that, the resiliency in telecom, they built the 5G technology. 5G technology will change a few things. I can give you an example. It's going to be changed infinitely everything, but a few examples you can relate to you. For example, Tesla started a self-driving car. And after the testing, they quickly realized that they have the technology to their car to move, but the car coming from the other side, they don't have that same technology. They are driving by human. The reaction time is both are different. Computer reaction and human reaction is different. Only way we can have self-driving car if we have car talk to each other. How can car talk to each other? 5G. You coming 5G with the telecom. What happened? You have to process the data itself. For example, car need to process and data when you need to make a right or left or what happened to a next move. Same to other car. When you see the other car coming to you, what do you need to do? How to avoid collision? You need to process data here. Here's come the edge computing. And edge computer, as I said, telecom, creating lots of Mac. A Mac will help us to get there. Mac will help to get to another point I'll give you there. We all heard about a smart house. What is the meaning of a smart house? Smart house could be a lot of things. First, we thought a smart house could be lighting control, your air conditioning control. We call that a smart house. That's not really a smart house. A smart house will be more than that. For example, let's say in future, you're going to have cooktop. They have a built-in computer processor. You need to make a tea. You just have the pot ready night before or coffee. You have thing in there. It's going to make the coffee exactly and turn off the stove and texting you. Your coffee is done. You're ready to drink. It's same as you making chicken curry. No problem. You put everything in there. They'll cook it for you and they'll text it to you when it's done and it'll turn off automatically. Same as biggest thing I think a smart thing can happen when we go to sleep. We're going to all age one day. And we will have some of them we're going to have some heart condition, breathing condition, or whatever thing is going to happen. Your room will have enough monitor with your phone or something else, which will be done by telecom. You'll notice if you have abnormal breathing or you're having heart attack, it's automatically call ambulance and they will come pick you up. So you don't need to worry about your mom or dad right now or future my daughter that you're worried about. I'm in middle of the night. I'm going to be falling behind or something happen. And this will take care by itself with the 5G technology. So resiliency in telecom is huge. They are building and we're going to learn. We are going to open up one layer at a time, but it's like an onion. It's more layer you're getting. You're learning new thing in there. Same as 5G, more layer we're gonna take off, and we'll learn something new. And that's the telecom sustainability technology we can see in future. Thank you.
So, Bablu, you were talking about sustainable technologies that we use in our everyday life, like the electrical car or self cooking stove and things of that nature that help improve the energy utilization and energy efficiency. Making those possible, enabling those technologies is what telecom is going to play a huge role in. Do you also see telecom using sustainable technology for themselves, the electrical infrastructure that they create? Do you see a role for, say, solar or wind or any of those technologies within the telecom infrastructure?
Great question. Actually, we all need to be first. When in a few years ago, when the telecom facility had a 1,000 amp service, just to say, 4,000 amp service or 500, 600 kW of power, right? This power is really insignificant compared to what they're going to see in future is 3,000, 4,000 kW power. You see the magnitude is 5 times. 5-time multiplication require it's a lot of power, electricity bill, and a lot of power. We need to this power has to produce from our coal power or wind, solar, whatever thing we've been doing. Its power has to come from somewhere. Telecom industry realize it. They need to more energy efficient. They're not doing energy efficient just for environment or other stuff. They're doing energy in efficiency. Biggest reason their pocketbook. For example, if you have 2000 kW of power need, that's with adding cooling energy, getting 5 megawatt of power. It could be if I reduce 20, 30, 40% of my energy, it could be $1 million a month. And they each has 200 to 300 infrastructure. It could be more even in future with the 5G. So if you're talking about billions of dollars savings, it goes to their pocketbook, their profit. So what they're doing right now is you mentioned solar panel and others. Before we go there, the telecom and data center biggest power hog is the air conditioning. That's the biggest revolution happening first. Then the telecom is addressing that. Before we use computer room air conditioning unit, or crack unit we call. That crack unit is very reliable, very religious, everything good. But the problem, that's a power hog, is all you know about PUE, we actually in mission critical live and die by PUE. So PUE, having PUE of 2.0 with a 2.0 is not acceptable anymore. A lot of country even forcing to PUE goes to 1.3. US is not there yet, but we are trying to get it to a good citizen and good for environment on our pocketbook. We need to get PU level 1.5 or less. To doing that, telecom industry looking at it different perspective. They use airside economizer to reduce their air conditioning cost. Also, they are using big air handling unit, which is more energy efficient. This could be a PUE of big air handling unit is 1.4 compared to 1.8 to 9. You see what's the power saving here. Already you're saving 40 to 50% of your electrical bill. But do you think we're going to stop there? No. This is the first step. And the way right now their biggest hurry is just build to keep up with the 5G invention. Now they are start looking solar. What telecom facility has, let's say, as I mentioned, 50,000 square feet of big infrastructure and has a huge roof. And that roof, 50,000 square feet of roof. The roof is empty. No equipment. They usually don't put equipment on the roof. If they don't put any equipment, this roof is empty. This roof is perfect for solar. The telecom industry slowly realized that they can utilize solar. Yes, solar technology is not there you can run the whole telecom, but you chop it up 25% of the power. You think about it again, as I mentioned, you're chopping up $1 million a month, and that's multiplied could be a 25 to $50 billion a year going to their shareholder and your net profit to your pocket. So yes, they are looking at it different way, but we're going to evolve with the time when the power need coming, more power need coming. Thank you.
All right, great, Bablu. Again, you're sharing a lot of insights for our audience to think differently and to kind of definitely think outside the box. So I want to remind you, audience, if they have questions they would like to ask Bablu during the live Q&A, please start populating your questions in the questions block of this webinar tool. So Bablu, let's move on to the fourth topic of telecom facilities and Internet of Things. Now, if I look at the power grid, and the power grid, everybody probably remembers at the minimum in their neighborhood, the power lines going through and the power poles, and maybe along the highway they see all these transmission lines. And so different elements of the power grid, or many elements of the power grid, use digital technologies that allow remote management, detailed management, instantaneous management of the systems and the distribution. And collectively, that is sometimes referred to as smart grid. So is that smart grid concept coming to telecom industry, or is there an equivalent in the telecom industry to the smart grid concept?
Great question. Smart grid is not triggered to telecom yet, but telecom itself monitoring their power, control and everything. It's more automation built in there, so remote monitoring, remote controlling, some of the things happen in electrical and mechanical, more so mechanical infrastructure than electrical infrastructure in there. So is smart grid, right now they're concept building the 5G. A smart grid will follow. Everything will follow by that. Because, as I mentioned before, the power they see right now is insignificant compared to what they're going to see in future. When they see more power, there will come more innovation, more things going to happen. Innovation will follow when people's need and hurt your pocketbook. So that's we're going to see in future. But right now, we only seeing telecom is start adopting EPMS system. EPMS data center doing for adopt few years ago. Telecom was lack. Now they are starting because telecom become data center. Believe it or not, some of the telecom gonna become data center. That's why it's gonna evolve and gonna happen. And some of the thing when it happened with the previous topics, probably I didn't mention it, but one thing we need to know, a lot of data centers, we build out of data center. Data center has a lot of computing power, but they are lacking the edge computing. As I go back to the edge computing here, they're lacking edge computing. With that could be fulfilled by telecom facility. And without edge computing, you cannot do 5G, you cannot do a lot of things what we envision to do. And telecom, you heard recently some big telecom company partner with a big data center company. It's more partnership you're going to see because of edge computing. And for example, another example on their video content, if Netflix grow bigger than what they have, their client base is, I heard last quarter, they got like 10% more users. If they keep going that, they need more edge computing. Like as I said to my daughter before, that my daughter's not going to wait 5 minutes to download a movie. So this will trigger more partnership for the bigger data center to telecom facility for edge computing. So as a smart grid and other stuff will follow after that.
Great. So then, along the lines of Internet of Things, which is the topic we're covering right now, or Internet of Things means most every element of that infrastructure has some level of digitization, some level of associated intelligence, and the data collection capability. And collectively, this leads to artificial intelligence or even predictability of infrastructure or our components. So is telecom industry using artificial intelligence? And if so, is it using it to improve the reliability or is it using it for other means as well?
Great question. Telecom facility using some part of artificial intelligence, but they're helping us to get to artificial intelligence to our end user. For example, again, I'm going to mention over and over 5G. When 5G happened, we heard artificial intelligence, saw in the movie, a lot of things we saw. It's like one day it's going to be our future. Nobody give us an answer when is that future is. Now I can tell you the future is, we can see the future through 5G. 5G going to make us automation, make us artificial intelligence so closely than what we imagine. So, for example, I can give you like a smart car, what I tell you before, that's artificial intelligence, a car driving itself and communicating each other. As a Internet of Things, you say, Internet of Things is like we used to have internet in our home. Now, I'm going to give you my teenage daughter. I recently bought a car for my wife. She wanted first thing, the car has a Wi-Fi capability. And my daughter first thing asked, can I get a telecom Wi-Fi service to the car so when we go to long drive, I can watch YouTube or doing other stuff, or I can do my homework during the car drive. So Internet of Things used to be home. It goes to servers everywhere. Our part goes to Internet. My phone, as I mentioned before I go to, I'm going to repeat this thing, but I'm repeating for a reason. When you go home, outside home, you're going to need your phone, only phone. On a phone, that means internet is a connectivity. Either you connect by cellular, which is 5G, or connect by Wi-Fi. Still, that has some element of 5G built in there. So that phone will be your security system, your credit card, your house key, your car key, and your computer. You can do a Zoom meeting from your phone. So Internet of Things is going to be more going to be in our life than we realize. I think some people realize it, but I don't think we can live without Internet nowadays. Biggest complaint I get from my household, I'm going to give you an example from my household. I have two twin daughters. They're 6 years old. Anytime their iPad not working, they come complain. The whole house is broke. What are we going to do? How am I going to survive? That's kind of language that little kids use when they don't have internet for a few minutes. So internet really a thing in our life, and it is growing faster in our life, and 5G gonna grow even more faster need for internet. And 5G automation, artificial intelligence, yes, artificial intelligence is gonna happen when processing done locally. The biggest problem we are processing data in the data center. And by the time you're receiving is latency built in, which I said, a reaction time is too great. So we cannot have that kind of reaction time. We did like shorter reaction time, like a nanosecond. So artificial intelligence is going to happen when you have nanosecond reaction. Nanosecond reaction or 0.001 second or millisecond reaction. That only time can happen when you have 5G infrastructure and telecom. Give us opportunity, everybody access up to 5G. So we will eventually convert human to robot. And that's the bad part of this, but it will be a better life for us. Thank you.
So do you see that evolving into some predictability of the infrastructure management?
Definitely. What happened now, a lot of things is like we're going to have a real-time data. A real-time data will give us a predictability of what can happen, what's going to happen. For example, let's see the telecom facility, we have a big event coming in our area, right? We can predict ahead of time how much traffic going to bring that thing in there. Telecom can do their infrastructure management such a way, hey, daytime, I probably don't need to run 4 chiller. I'm just giving a chiller example. But I have 4 chiller in is big event happening in this area and something coming this area. I need that 4 chiller to turn on. I need to have some of the predictability. You're looking at a live data each time and seeing what's going on, how it's growing, and you have a reaction time to adopt that quickly. So it will definitely have some predictability of infrastructure, how we need to grow. And same time, it's giving you lifetime data, how we're growing that area, and that they have us to plan for future. What do we need? What kind of infrastructure we have? Is this infrastructure is capable of handling what we're seeing in a horizon? So predictability going to happen with a smart AI, yes. And this process will be done by computer. We don't need to do a human computer and tell us, warn us. This is what we need to have. This is the growth has to happen. Here we need to have. This server getting old. This server drawing too much power. This server getting lifetime is done. So that kind of thing is going to happen throughout the artificial intelligence. And that's going to help us end user to get there.
All right, great. Thank you. Thank you again, Bablu. I think you've shared so much insights for our audience to benefit from and start thinking. And I'm sure the questions in the chat box will reflect the out-of-the-box thinking that the audience has to go through. So let's end our recorded conversation here, and let's meet the audience on the live Q&A. And we are live. Hello, Bablu. Welcome to the live segment of Industry Perspectives, Telecom Facilities. So it seems like we don't have a whole lot of time left, and we have a very enthusiastic audience with us today. So let's dive right into that questions. And the first question, there's a couple of questions surrounding this topic, but the question surrounds the events happened in Texas last week and the reliance on single technologies, reliance on similar pipes. And so the question is, what happens when a situation like what happened in Texas happens elsewhere, because weather-related events seem to be happening more frequently than before, and now your connectivity is disrupted, and you painted the picture that our smartphones are the only device we need for our everyday life because they are a computer, they are a phone, they are our communication device, they are our work device, they are our unlocking device, they are our security device, they are everything, right? So the question is, how do you depend on this one device and the infrastructure breaks down because of situations like what happened in Texas last week?
That's a great question. Actually, most of the time, telecommunication facility is a build their infrastructure thinking of this kind of thing ahead. They think always disaster could happen and they can lose power, this, and they're prepared for it. And there's no such a thing you can prepare for everything, but they have power backup at least 72 hours to, like, it sometimes even depends how much load go through, traffic goes through there. They prepare for their stuff probably for a week. They can survive without power coming from outside. So your biggest problem is make sure you have enough phone charge, and in a disaster happen, your phone have enough juice. If you have enough juice, you will find information. When disaster happening, biggest thing we are lacking is to find the real information. What I need to do, what I can do to mitigate and make my life easier, what I can go and get my help. Telecom is perfect. They will give you information. That's the place you can get all the information. I hope that's answer your question for this one.
Yeah, and the other question along the same lines, again, severe weather seems to become more frequent. And so from a design philosophy standpoint, has anything changed in the telecom facilities in terms of electrical reliability? And maybe you started to touch on that, but is there anything else that you want to add from an electrical reliability standpoint that the telecom industry has adopted as their designs?
Telecom switching and telecom tower, all the signal goes through tower, right? As long as if they overbuild tower and they have lots of tower redundancy built in there, so all the signal has to go to the tower, even though they're switching working properly, but your phone call is going through, or your signal going through the tower, cell tower, which I said before. In 5G, they're going to build a lot of tower, and that's going to redundancy going to, because of need of the 5G, redundancy going to build itself. You're going to have more 100 million more of tower. So what happened is a disaster happen. If one tower doesn't work, there's going to be another tower nearby is going to work. And there is, again, I said, you cannot 100% mitigate everything, but you will mitigate most of the time the problem we have.
Okay. Again, there's a lot of questions, and we're going to try and address as many of these questions as possible on the live session. But those that we cannot, feel free to reach out to Bablu directly and ask him the questions. The next question is surrounding the infrastructure strategies within the telecom industry and developing best practices, and how does the telecom industry learn from each other's best practices, right? So there are examples where companies like Facebook, Google, Microsoft, all of them have published their data center efficiency results so that they can learn from each other, but the broader industry can also benefit from their research. So do you know of any similar things happening in the telecom industry where the industry is sharing their research and kind of helping the broader industry benefit and progressing forward?
Good question. Yes, I'm going to try to make it like a different perspective. The telecom industry become part of mission critical industry, and data center is the same thing. So we are same people who are doing mission critical and doing data center and telecom. It's all sharing infrastructure study knowledge each other. So we are learning from each other what's going on, what industry perspective we have, what's our need is, how we can make efficiency. Everybody care about their pocket bit, their electricity bill. They want to make power is more reliable. Everybody's goal is to have more efficiency. So that's perspective inter-industry. It's just working together. In the future, he's gonna see it's no difference. This telecom data center, all they're commingled together and just have a one big mission critical infrastructure.
Okay. The next question is, related to obviously the lockdowns that many parts of the country are still experiencing and resulting into remote work for many. And so the question is, can typical telecom facilities themselves be remotely operated, or do you have to operate them in physical presence only?
Most of the telecom facility auto run more because it's like you need somebody to go there, but it's like you making phone call and the phone call going to the server is processing that data and going to the other side of the user. So it's mostly auto run. Yes, one or two people need to go to the site sometime. You got to look at it. Hey, this aisle getting hot, getting some alarm or something. It has automation built into telling you what to do. Most of the day you're probably not gonna see it. People need to go there and do anything. If something happened, they have enough built-in warning system, alarm system, so people can go there and take care of stuff. I hope that's the answer question.
Yeah, no, I mean, again, I guess every industry has a little different perspective on remote work, and good chunk of it could be done remotely, but some physical presence is required for either confirming or double checking or for ensuring that you're doing the right things. The next question, again, you had touched on the fact that telecom is becoming sort of a data center industry, and especially 5G is cloud-based, and so there's a lot of data center type environment and the blending of maybe even data center industry and telecom facilities. And so along those lines, the question is, because I think you touched on resiliency and the need and importance of resiliency, that the question is, does 2N or 2N plus 1, the typical Uptime Institute type of infrastructure designs, are those redundancy designs not enough, or do they need more for telecom to improve their resiliency?
Great question. I think people who works in data center or design data center, 2N generation. We're talking about generation most likely here. Redundancy, what built in the generation generator, how it built in there. 2N is enough. How you design, how you implement it. Yes, you can have 2N plus 1 to get a little bit more ahead of that. But if you design and implement it properly and think outside the box, even 2N system, you can make 2N system as a 2N plus 1. There's a way to do it. So 2N is more than enough. You have to think about it. 2N means you have 3 or 4 means a method to failure before you really fail everything. So you have to fail the whole utility system. Then you have to fail one of the generator, and then fail the second generator. It's like if you put a probability, I'm not saying it cannot happen, but if you put a probability and if you maintain, and maintainability is the biggest thing, and to capture rather than the thinking about 2N plus 1 other stuff. You need to mitigate the disaster ahead of time. So how we can do it and make sure your generator exercise properly, your generator run properly. You have any fueling issue, check the fuel all the time, yearly maintenance. All of this thing is depend on how reliable you can make your infrastructure. Yes, so reliability, maintainability is the biggest thing to make sure you don't get a situation, then you have multiple failure. You can have 5N or 10N, doesn't matter. If you don't maintain, it's a Murphy's Law. When it start things falling apart, it's gonna fall everything apart. So nothing you can do about it. But if you maintain all the time and you check everything working properly, is the disaster happen, it should work what you're testing throughout the year.
Yeah. Then the next question is, maybe you've touched pieces of this question in your earlier responses, but maybe if you can kind of clarify even further. You had mentioned the need to have telecom systems integrated with generator and transfer switches. And so the question was, how can such a system alert personnel via telecom when a utility power is lost? So, you lose the utility power, the telecom infrastructure is your backbone for communicating and even informing about a potential utility loss. So how can you use that sort of a system to alert? Can it be only done through Ethernet connection, or do you have other means to communicate?
Yeah, that's good question. That could be done so many different ways, but Ethernet is the most popular use. What happened, like you transfer switch, most of the transfer switch I know, a smart transfer switch has a alarm built in there. It's called utility fail, right? That's alarm goes to end user automatically, and end user see it, hey, and you can see it from the not only there, it's they also call knock can see it, hey, your utility failed this site. You make sure your generation is working. If your generator not working, somebody need to go there as soon as possible to make sure everything is working. Everything need to pay attention. Yes. So answer your question. All this smart feature is built in there, but how much end user is using, that's depending on it. Again, I'm gonna say it, maintainability testing. Make sure you test it over time. Make sure when the utility fell, you get this alarm, you know what to do, how to react. That's all the disaster plan has to happen. Otherwise, you can build the most smartest thing in the world, but if we don't practice it, how to react, it's not going to work.
Yeah. I know we're kind of up on the hour, but let's try and take maybe one more question. This is an interesting question that electrical engineers are in shortage, I guess because the universities are not offering as many electrical engineering focused curriculums, or people are not choosing that as a curriculum. So how does this impact telecom facilities electrical infrastructure?
That's a great question. It's not only telecom, it's all electrical infrastructure, but telecom is more so because we are telecom and data center mission critical. I'm going to say mission critical instead of telecom. People are specialized in this. They need to understand reliability. They need to understand redundancy. They need to understand cooling. Even though I'm an electrical engineer, I got to understand that what's the cooling is doing my data center, what we need to do. So let me say this simple way to say it. If you think about the data center is your body, heart is electricity, but oxygen is a mechanical system. So if either or fail, you're going to have a disaster. People in our industry, it is what we're seeing, and I don't know, it could be other people. I'm just giving you my experience. We're not finding quality people to do data center design and understand this kind of thing. People are engineering, in more people going IT than engineering, and that's creating a vacuum for us to find real qualified engineering to do electrical infrastructure. This challenge for us, I think, it probably a challenge for your industry, a challenge for everybody.
Yeah, I will second that the shortage of electrical engineers is a broad challenge, not just limited to telecom. And there are some statistics that say there are 10,000 engineers retiring, say from industries like utility or similar, and only 3,000 or 4,000 backfilling those jobs every year. And so net shortage is going to continue to grow and become even more severe as time goes on. Obviously, we cannot get to every single question, so I encourage audience that we could not get their questions answered to reach out for Bablu and continue to have the conversations. I want to thank you, and let's bring a close to this event. I want to thank Bablu of Morrison Hershfield to share his thoughts and taking the time to share his experiences with our audience. We learned a lot of new things today. I also want to thank our audience for their participation and engagement. You flooded our event with questions, which makes this discussion even more interesting and informative. Again, thank you for joining our event today, and see you at the next event from ASCO Power Technologies. Goodbye.